Okay, I should be recording. Sorry for the weird webcam angle, but there's some people sitting more to the left.
Oh,
And,
hello, everyone.
they're sort of spread out. This is sort of where we work here in
Sure, it's all good.
the University of Lisbon. And I'm going to put it like this, and then I'm going to sit down. But first of all, welcome everyone to Professor Nick Martelaro's talk. This is part of the Cmu Academy, so this is part of our UX and service design program, but we also have some students from project management, and we have some students online and some faculty online actually from other institutions as well. So there's some people that are quite curious to see your talk. So Nick is faculty at Cmu since 2020, if I'm not mistaken, in the HCI group, so the Institute for Human-Computer Interaction. I actually met Nick maybe 10 years ago. I don't know if you remember at Stanford when Stanford was hosting TEI, which is the ACM conference on tangible and embedded and embodied interaction. So it's really nice to see him again. And it's time goes by really fast because I was trying to remember, and then I realized it was actually quite some time ago. So Nick has, I'm quite curious to see what he's been up to, and he has this talk on building to see, building to act, that he's gonna share with us now, and I'll let him introduce himself much better. And I'm gonna mute myself, Nick, and then I'll come back as soon as you're done.
Sounds good. All right. Well, thank you everybody for inviting me. I'm excited. I wish I could have traveled to Lisbon because it is just starting to snow here in Pittsburgh. Right now, it's actually pretty dry, but there's like little flurries of snow. I imagine Lisbon's weather right now might be a bit nicer. So today I want to talk a little bit about some of the work that I do to think about how designers and folks who are building things can develop systems that allow them to observe things in the world better, to understand users better, but also to prototype new interactions. Today, I'll be talking a lot about interactive physical systems, but I think that this work can actually be inspirational even for digital systems, just if you sort of think about it in sort of a creative way. To get started, I'll just give a little bit of background about myself, just so that I set the context here, so you sort of understand why I look at the world sort of the way that I do and how I approach some of the work I do. I actually started my career as a mechanical designer. These are projects that I did in undergrad. I used to build off-road race buggies and gearboxes and little engines and things like that. And I really loved building sort of physical systems. When I went to grad school, though, I realized that, whoa, we can add computers to all these things and make them highly interactive and interesting and exciting. And so I actually ended up, my sort of technical background is really in mechatronic product development, sort of interactive product development. These are just a sampling of some of the things that I've built, things like robotic couches, interactive stereos, computer vision-based ambient displays, automotive interaction interfaces. And I'll talk about some of these things today, but this is sort of kind of a breadth of things. So again, I really enjoy thinking about myself as a designer, building interactive physical systems. Before I was a faculty member here at the Human-Computer Interaction Institute at Carnegie Mellon University in Pittsburgh, Pennsylvania. I actually worked as a technology R&D principal at Accenture Technology Labs in San Francisco. And there I was doing a lot of explorations in new interactive technologies and how they could be applied to create sort of interesting, exciting, and in some ways we would sometimes use the language like sort of magical experiences. A picture here on the right shows me with a sewing machine. We were actually doing work. I was starting up some new work in smart materials, interactive, sort of electronics embedded fabrics. And I'm probably one of the first or maybe only people that has pulled out a sewing machine inside of a consulting floor at Accenture. And then here on the left, there's actually a picture of this interactive system I built for a large animation client that would recognize when you were taking a selfie with it. It was a poster, a digital poster, and then it would come to life, actually. So once it recognized that you were taking a selfie with it. And we were using some really exciting, at the time, very new sort of body pose estimation algorithms, many of which were actually developed here at CMU, and thinking about how we could apply these to create these really exciting interactive experiences. So hopefully this gives you a sense. I really like building things. I like building interactive experiences, and I like building things out in the real world. So in regards to what I do, I build design research. For my research, though, is that I actually build design research tools and I study how they influence design processes. So my work here at CMU and a lot of really my research interests lie in sort of developing tools and methods to help designers like yourselves do better work. Again, as I've said, I sort of focus a lot on interaction design for autonomous physical systems. So thinking about things that are out in the real world. And this includes things like autonomous cars, personal robots, digital assistants. Actually, all of these photos here are really great product photos from the representative companies. But one of the things that I find really interesting about these photos is that aside from the Jibo photo, Jibo is a now defunct personal robot, home robot that actually has very beautiful interaction design. It's the only one here that actually shows a picture with people. But I find that kind of weird because actually, once you get away from sort of the tech and the sort of beautiful industrial design here, everything is about the interaction. Everything is about how do you as a person interact? How does this car take me to where I want to go? How do I reserve the ride? Do I communicate with the car? What if something goes wrong? Same thing with the Amazon Alexa over here. Actually, all of the exciting parts is not really about the fact that it's this beautiful black cylinder, but it's really the fact that it can talk to me and I can actually have it do stuff for me. And so really that interaction between sort of these objects is what I'm really interested in helping people figure out how to design. And I'm quite motivated by this quote from Terry Winograd in The Design of Interaction, a 1997 book that he wrote, that states that successful interaction design requires a shift from seeing the machinery to seeing the lives of the people using it. And this has really been foundational for a lot of my work and a lot of how I think about things, shifting away from creating cool technology, which I personally love, have an engineering background, I love doing it, but really thinking about how this is going to fit in people's everyday lives. How is this actually going to make something that they're trying to do better? So today I want to talk a little bit about some strategies that I've sort of used and developed to think about doing this with these sort of new types of interactive physical autonomous systems in the world. I'll first talk a little bit about building to see, so helping to kind of think about how do we see and understand our users in a richer way. Then I'll talk about need finding machines, which is sort of this methodology that I've sort of developed as a way of thinking about observing and prototyping interactions. So thinking about how you can actually develop systems that can help you develop these interactive systems out in the world. And lastly, I'll talk a little bit and give some examples about building to act. So not just seeing and observing people, but actually trying things out, testing new prototypes in the world as a way to understand interaction and prototype these new, exciting, interesting experiences. So we'll start first with building to see. So I like to actually ground a lot of my work in examples. So that's what we're going to do pretty much all throughout the talk today. And actually, one of the first projects that I worked on that was sort of in this space was a collaboration with Renault Nissan. They actually had a question about how can we understand the driver experience with currently available autonomous driving systems. So Renault Nissan, they produce a number of vehicles that actually have varying low levels of autonomy, so adaptive cruise control, adaptive lane keeping, sort of these things can sort of drive on the freeway mostly on their own, but of course with forms of driver engagement. And they knew that these products were generally safe, they knew that they functioned, but they had very little understanding about what it was like for someone sitting there. They had all this telemetry data too from the vehicles. So they knew that people were sometimes using it and often not, but they didn't really know what it was like for that person sitting there, which I found to be a really interesting thing. And so I wanted to understand, is there a way for us to understand that experience in a really rich and realistic way? Let me show you an example of what sort of driving in, I'll say at this point, this is like circa 2017. looks like in sort of an automated vehicle driving down the freeway. This, in this case, this is actually autopilot in a Tesla driving in the San Francisco Bay Area.
What are you paying attention to right?
Straight in front of me. But I think that's useless because the system looks really good.
So what's going on here? So one of the things you can see is this driver is actually in autopilot. So they're totally hands-free. They're driving down the freeway. And in this case, they yawned. Now, we have a video camera set up in the vehicle. This is actually a live view that, in this case, I'm actually watching remotely. This is during a test, so this isn't some kind of covert thing. They're aware that they're part of a test. And then if you look here, you'll see this small little silver thing. That's actually a little microphone. And you heard that voice, that sort of robotic voice, like, what are you paying attention to? What's going on there is actually what we're doing is we're sitting behind the scenes, sort of in a mission control, and we're watching and then interacting with this person, trying to understand what their user experience is like. This is really a common strategy of doing, say, a user study or a contextual inquiry, except that we're doing it remotely and we're doing it sort of under the guise of an autonomous system, sort of a robotic or AI system that's asking these questions. And this is a way that we're sort of using to basically put designers in the loop of realistic interaction that's happening out in the world as a way for them to observe and understand what real world experiences, especially with autonomous systems like a vehicle, are like. So what's going on here, like I said, we're actually using a technique called Wizard of Oz prototyping. We are really inspired by that. This is where you have a person behind the curtains. So in this case, that was me. And we're watching on sort of this mission control, and we're sending all this data from the vehicle. Actually, at this time, we can send telemetry data from the car about the systems, what's working, what speed is it at, are the brakes engaged, are the brakes not engaged, is the adaptive cruise control engaged? And then we can actually ask questions and sort of interact with the driver. But we use this robotic voice as a way to sort of remove ourselves from the situation. It's a little bit odd at first, but actually it makes it so that people can sort of think, oh, I'm not actually talking, someone's not just sitting here observing me like with a clipboard, like I'm in a lab, but I'm sort of just having a conversation with something about what my experience is like. So in regards to what this actually looks like on our end, here on the left, you see a picture. This is actually a designer at Renault Nissan. They were interacting in this situation, and you can see they have this sort of little mission control. They've got multiple channels of video coming from the vehicle, both looking out the front of the vehicle so that the person understands what's happening on the road ahead, and they can sort of temper when they speak to someone, making sure they're not speaking to someone when it's really complex, maybe when it's a little smoother, there's less going on outside. They also have a video of the person, sort of that side view that you saw before. And then they have this control interface on the right. This actually shows different information, telemetry information about the autonomy system. So for example, ICC stands for Intelligent Cruise Control. So they can see that it's enabled, they can see that it's engaged. The set speed is 65 miles per hour. The following distance is set to short, so that's sort of how closely the car is. And then if the brakes are engaged. And then again here, what they can do is they can actually send these messages. They can basically speak to the driver and ask questions through this sort of computerized voice. We would recommend a lot of sort of common questions like sort of user research style questions, but often people ask questions that were really relevant and related to the design work that they were doing. What's actually going on in the vehicle is that we are basically kitted it out with a number of sort of Internet of Things technologies. We set up sort of a computer, we have a 4G router, we then have multiple cameras that are running into a video mixer, and then from there we've got a microphone, and if we ever want to, we can put other kinds of interfaces in the vehicle. We've used this in the past for prototyping. We can put touchscreens and then bring up sort of sample interfaces. We can put physical interfaces, buttons, lights, and we can sort of prototype those things. But the main thing here is that what we're able to do is sort of be remotely there. I will say that this doesn't feel so special today in sort of our totally remote, like the fact, I mean, we're live streaming and I'm giving a talk now. I will say in 2017, this was pretty exciting. Like we were just getting high enough quality 4G routers that would allow us to send multiple channels of high definition video live and actually allow us to understand and see what was happening in real time in a car. So this was sort of very, very exciting. What this ended up looking like back then was this sort of big kit. We had this cool kit that had the video mixer. We had a laptop in the car, sort of battery backup, and we would basically put this in people's vehicles in their trunk or in the back of the car, and that would allow us to sort of send all this data and all this information back and let us run these studies. Today, we probably can do something like this with maybe like 2 cell phones, but back then it was a little more challenging to do. So a little bit about the deployment with Renault. So this is sort of a technical way of doing this, but what did they actually want to learn about in this study, and how did we actually do this? So like I said, they wanted to understand what the real world experience was of people who were using their adaptive cruise control and safety systems, and understand what that kind of felt like for them. So what we did is we actually ran 12 interaction sessions on people's real world commute. So we didn't bring them to a test track. We had this in the real world. In the San Francisco Bay Area, people's commutes can be roughly 30 to 90 minutes and roughly 10 to 60 miles. Apologies, I should have converted to metric. But you get the sense this is far and long. So it's a decent amount of time that we're spending. And the thing is that we're actually going to people's either from or to their house. So we're not just sort of sending them on a random drive. This is their daily commute. This is exactly what they would experience sort of every morning or every evening. In addition, what we did here is we had 9 professional engineers and designers who were really interested in trying this out. They're these sort of wizards. They're the person behind the curtain there asking the questions. So this isn't actually me or people from my research team who are asking these questions. Instead, this is actually real world designers who are interested in thinking about how to design their specific systems better and then in understanding that user experience. So I'll show a clip here of a car in cruise control, and then what happens when there's an obstacle and the car automatically brakes. Then what you'll see is that the wizard in this case, the sort of person who's behind the scenes, they're going to ask a specific question.
Did you feel the system intervene to brake?
Yes.
Did you feel that was safe?
Yes, I felt it was pretty smooth, and it started applying the brakes about when I would have, so it felt early enough that I didn't need to intervene myself.
So in this case, the person who's actually sitting behind the scenes and asking the questions is a controls engineer. Their job is to basically make the adaptive cruise system function well and really to function smoothly. And one of the things that they were quite interested in was understanding how sort of smooth and then perceptually safe it felt. So again, these products are out there, they've been tested, they know that they're generally safe, but it's sort of like, what does that feel like? Does it feel safe? Does it feel smooth to someone, or does it feel sort of jerky? So in this case, what they're able to do is they were actually able to see, okay, the car automatically hit the brakes. In this case, the driver didn't disengage, so they didn't overtake with their own foot by braking. So the system hit the brakes automatically and then resumed its sort of cruise control. And the wizard sort of asked, did you feel it for one? Because in theory, you should be able to feel it. And then also if it felt safe, because they were quite interested in understanding, like, okay, well, how smooth does a safe brake feel when the car actually takes over? What's interesting about this and exciting is the fact that they're able to actually align this moment now with the telemetry data, so they could take a look at back and actually see sort of when the brakes engaged, sort of the acceleration curve and the acceleration profile that's felt in the vehicle for how smoothly or jerky that brake was happening. And then they can cross-reference that with what the person is actually talking about. one of the things here that's also really exciting is the fact that this is something that you can ask about. That's a moment that can happen probably many times during a drive, but that it's really hard to ask someone about afterwards. If you were to have someone get out of their car at the end of a 30 or 90-minute drive and say, hey, how did the cruise control, like, did it feel smooth? They'll probably say, yeah, I guess it was smooth. Now, it's possible that they might have some acute incidences where it really wasn't smooth and they'll be able to tell you about it. But by actually watching live, by actually having the telemetry available, you're able to really tightly couple a instance that happens in the real world and then actually ask what people are thinking about. We often want to understand, like, what are people thinking? How do they feel about stuff? And by doing it really close together, you're able to hopefully get a more realistic and honest answer from them, as opposed to them sort of telling you, well, in general, this is how this feels. I'll show you another clip. In this case, this is an instance where the system does function, but the user has a significantly different reaction to the automatic braking.
Whoa.
The next exit is what you would take.
Okay, that really scared me, just to let you know. All the traffic stopped, and I was on cruise control because I normally wouldn't be on cruise control, but the car really slowed down. It was nicely.
Can you tell me more?
Well, I was traveling, you know, my set rate, which I think it was around 68, maybe 65, and all the traffic came to a crawl about 20 miles an hour, and I was a little distracted, but the car like just totally slowed down.
So in this clip, the car automatically brakes, but you see that this driver actually has a pretty acute reaction. They sort of, ooh, they're a little bit scared, and they're sort of like, whoa, that actually really took me by surprise. This is actually a really common occurrence. This happens often in these vehicles. And it's partly because people may not always be paying attention, or partly because the car does something even when the person doesn't recognize that that's why that it should sort of slow down, because basically the radars are maybe capturing something in the view of them. And so this one was a really interesting sort of moment to capture, especially because the engineers, they understood that this is happening. They can know that they can look at the telemetry data and see that, you know, sort of the cars they're doing that, and even they're braking pretty hard because that's the safe response. However, they'd never really seen this sort of interaction of people sort of getting sort of emotionally like, whoa, that's kind of scary. And they had realized that, man, we probably need to think a little bit more about that. Like, how do you help moderate that? How do you help someone understand that actually what's happening is safe? Because what used to really happen a lot was that people would sort of have an experience like this, something that startled or scared them, and then they would just turn the system off. And so then all of the work that went into building sort of this nice adaptive cruise control that likely could actually make driving better, it could make driving safer, basically gets turned off. You have all this electronics, all this hard work that basically the driver paid a lot more money for this vehicle for, and yet it doesn't get used. And so it's sort of moments like these and being able to see them in a realistic way that sort of can help to spur and kind of motivate new interaction design that might happen for, say, the in-car information system. Could this actually provide information of like, hey, it's okay, like it was supposed to happen, right? Actually, everything's fine here, right? How do you sort of help someone understand what's going on? So this actually got them thinking about that, which was quite exciting. I'll show one last clip here. This is back to that Tesla actually, but sort of an interesting interaction that we had where we discovered things to questions that we didn't even really know we had. And it sort of allowed doing this type of work, so sort of this remote, observational, and contextual inquiry work can kind of show us situations that we hadn't really even planned and potentially give us ideas that we weren't even thinking were important at the time. So again, we were interested in sort of what's the overall experience like of using these autonomous systems, but this clip sort of shows something slightly different.
How is the build quality?
Not that good. Not that good. For I mean, this car is roughly 130 km, I think. So I think it's not good enough.
So in this clip, the driver is sort of they're relaxing, right? The car is kind of coasting along on its own, right? They're exiting the freeway. And then they notice that the door is squeaky. And actually, it's one of these things where you might not actually notice when you're fully engaged in driving how rumbly or squeaky your car might be. But in this case, when you start to actually not think about driving as much, now all of a sudden the interior experience and all the sort of small potentially quality assurance details about how tightly panels fit, is something squeaky, is something loose, right? All these things actually start to matter more. So this was really an interesting thing we hadn't at all planned for, but by the fact that we were sort of on these realistic drives, we were able to be with these people for sort of hours at a time. We were able to see all these kinds of interesting interactions and then ask about them, right? So the main thing here is we see that interaction of like, no, he's playing with the door a little bit to realize that it's sort of squeaky. And then we ask that question, sort of how's the build quality, to get a sense of what they're thinking. Again, it's this tight coupling of situations that happen in the real world and then being able to ask immediately about them. So I'll give a few user insights. So this is sort of like what we would typically take away, and then we might hand to, say, our user research teams, which then might go to our design team to think about new ways to sort of enhance an experience. So some of the things that we found were, one is that drivers are actually experiencing a range of emotions with their automatic systems. So thinking back to that situation where the driver was startled and actually seeing that sort of visceral response, this is something now the team was like, all right, we probably should think about this. Another one is that actually in this case, the sort of driving with an autonomous system can make the rest of the experience boring. And people can start to lose vigilance, right? We saw in that clip of the yawning, we saw in the clip of sort of playing with the door. And it sort of presents new interaction opportunities, though, of like, well, what do we do when now we don't have to drive? So what else about this experience? And it sort of, from the vehicle perspective, makes it the interior experience matters in many ways a lot more. And this was actually quite exciting to some of the interior designers who were thinking about this. Now, as I mentioned before, a lot of my research is about studying and understanding, well, how do these tools and how do these systems sort of change the way that people do stuff? Because there's a lot of kind of funny things here, right? Like we're doing this remotely. We've got this sort of, we're behind a bot. We're not just sort of like on a call with them. But actually, there were some really interesting things. We spoke to all of the people who were at Renault Nissan, who were on the wizard side, right? They're on the back side of this, to kind of understand like how did they see this and how did this sort of change the way they think about sort of user contextual inquiry. One of the things was actually they found that being remote allowed them to see a lot more information than if they were in the vehicle, right? We could set up multiple cameras. We often would do 2 to 4 cameras. They could see all the live telemetry data. We could show that on a nice data table. So they were actually to do a lot more than if they were sort of sitting in the front seat or the back seat, where they can't look at the driver and look at the road and look at, maybe a data display, and also probably have either a clipboard or a phone, try to record all that information. The other thing too is that actually the bot alibi, which is a little bit odd, it was something that designers actually said allowed them to sort of observe more and sit behind the bot, as opposed to having to make a lot of small talk. Actually, it's something for those who've gone through training to do user research. We're often trained to kind of keep a conversation going, right? Keep up questioning, develop rapport, and that's great and definitely something you want to do. But it was really interesting for the team here to say, well, actually, this bot doesn't have to talk all the time, so I can just sit back and observe and just see what's going on, which was actually quite different from sort of experiences where when you're in the car with someone, sitting there and just watching someone the whole time might be a little bit odd and awkward. And so again, this is also something that helps to kind of reduce that observer effect that we might see when we're sort of out there in the world observing people. And in that way, we sort of found that this sort of remote interaction actually can amplify the amount of contextual inquiry we can do. We can actually see more of what's going on, and then we can ask more questions in some ways more pointedly, and sort of with less of a judgment, say, from the user researcher, because they were sort of behind this bot alibi. So now I'll talk a little bit about what does this all sort of like kind of come together to let us do. And I'm going to give an example of sort of a product, a sample product. But basically the idea here is we're thinking about how to understand people's needs, how to think about our users, and understand their interactions in the world, and then how we might be able to address challenges or situations that they're experiencing. So I talk about this as need finding. So for those who've had any design thinking experience or classes, you've probably heard this term, but need finding is defined really as an active process of perceiving the hidden needs of specific groups of people. Specifically here, I want to focus on a couple aspects of this definition. The first one is active process, right? This is something that we go out and do. So while many people oftentimes, you probably look at stuff and you're like, oh man, this is not that great. This could be better, right? Where you sort of see this stuff more passively. We actually take, as designers and product development teams, we try to take these active processes to say, okay, what can I do to actually go and understand users' needs in a more direct way? The other thing too is that we often are looking for hidden needs. These are things that people often can't tell us, but that we may be able to see, and then through conversation around the interactions they're having, around the things that they're doing, the way that they're working, the way that they're using products, we can actually recognize things that really they can't sort of say themselves. And then the last part is that specific groups of people were often really interested in understanding people who are actually using a system, who are actually doing something in the real world, rather than sort of just thinking about sort of general audiences of customers or users. So we're really thinking about sort of our customers or our users in this case. So now, when do we do need finding? I like to sort of plot it out. If folks know sort of the Design Council's double diamond of thinking about sort of processes in the beginning, where we're basically going through divergent and convergent processes of ideas. So we think of a lot of ideas, then we sort of down select from there, and then we prototype a lot of ideas, and we down select from there, sort of broken out into these two phases of what's the right thing to do, and then what's the right way to do it. Oftentimes, a lot of need finding activities, sort of user research activities, traditionally happen at the front end of a design process. And this is great. This is where we're sort of understanding what it is we should be going out to develop. Now, this being said, I actually think, and myself personally, I've done a lot of need finding and have sort of learned a lot when we start actually putting prototypes and ideas in front of people. And so once we start figuring out what we actually think we might want to develop, and we get that in front of someone, that's often when people start going, oh, I don't really like this. I think there's been countless times where I think I have a good idea based on user research that I did in the beginning. I put a prototype in front of someone and they're like, this isn't great. But the interesting thing is that it actually exposes a new need or a new desire that I hadn't even uncovered before. And so I'm always quite excited about actually using prototypes and interactive experiences as a way to do need finding. Now, there's this last bit, and I'll say I come from the world of sort of hardware, where we sort of ship a product, and then that product is out in the world. And often we used to not get a lot of feedback on it. Today, because things are computer connected, they're actually sending telemetry back, we can treat a lot of hardware and physical systems more like the way we sort of treat software, where we can have continual understanding, and we can basically do continual need finding around these products. I actually think that Tesla is really good at this. They have a lot of telemetry data, and they're constantly understanding how their users are using their vehicles, and then they're constantly sending out over-the-air updates to basically change the experience of their cars, which is quite impressive from the fact that this is, the automotive industry typically wouldn't be updating vehicles and their capabilities without really, serious shop work. So I'll talk a little bit about then what I'm sort of trying to do with some of the systems and the tools that I'm developing and sort of the experience that you saw there. So if we think about traditional need finding as an interaction between a designer and a person, and say a person with their with a product, sort of that cube there, traditional need finding is sort of done through a number of different strategies. Things like rapid ethnography, going out and actually observing people, contextual inquiry, asking people about their work, putting out design probes, so putting out new product concepts, really simple things, sketches, trying to understand what people are sort of experiencing, or even doing things more recently in a remote way. So experience sampling. So, if you've ever had sort of a daily text message, hey, can you tell me about this experience you're having with this, or actually doing more remote ethnography. So the way that we do things today often, right, is just hopping on a Zoom call with someone and talking to them or observing them. We do a lot of this in software. I think what's exciting is that we can start to do this now much more in hardware. So I will explain sort of this with a as if we were designing a new toaster. I'm not going to claim that everyone here should be designing toasters, but it's 2024, and we can now put AI, we can put cameras, we can put computing, we can make the toaster talk. Again, not saying that this is actually something people should run out and do, but I use this as an example of how we can sort of imbue this type of need finding process into physical products out in the world. So because this toaster can do all these things, it can now have this really interesting interaction with a person, with your user out in the world. And much of what we're doing as interaction designers is we're trying to think about what that loop looks like. What does the toaster do, and how does the person respond? So what does this interaction look like? That's what we are trying to design. What's exciting, though, is the fact that we have all this computation embedded within this product now. We can actually feed information back to the designer. We can get telemetry data back. We can basically, if the user sort of allows them to share data, we can share that data back. But what's actually exciting is the forward arrow here from the designer to the toaster is we can actually start to control, change the toaster. And actually the thing that I've been thinking about in sort of the work that we're doing here is sort of we can actually sort of remote in and be the toaster. We can actually fake being the toaster and have it interact in different ways. So we could sort of control what it says. We can control aspects of what it does to whatever sort of telemetry we've put in to kind of make it interactive. And what's exciting about this is that it's not just a toaster that we maybe test in a user research lab, but it's a toaster that we can now test, we can put out in someone's real world environment, so their real kitchen. And we can start to see what that interaction looks like between the person, the toaster, and their kitchen. And we can even start to explore interactions that people are having with other appliances. So the toaster could ask, hey, tell me a little bit more about what you're cooking. Like, actually, do you have challenges with this? Oh, if someone says something, oh, my fridge is on the fritz or something. Oh, tell me more about the fridge. And we can actually learn a lot more than just sort of the interaction with the toaster, but the interaction situated within a larger sort of context of sort of the entire kitchen environment. So now these systems are sort of what I kind of talk about as a need finding machine. And so it's something that we're imbuing, a physical thing that we're imbuing with the ability to basically allow us as a design team to sort of do this sort of remote contextual inquiry need finding activity. What I do is I build these things, and then I've actually studied sort of how this impacts design teams. So that's what I was telling you about before, sort of how does this change the way that a design team actually does its user research? How does it actually allow them to do different things to design new experiences? So to just put sort of a concrete definition on this, I talk about a need finding machine as a product that designers interact through. They sort of become the toaster, become the machine, as a way to understand user needs in relation to a specific context. It's embedded in some product or device that it's itself embedded in the user's environment and in everyday life. So that's our goal here, right? We're trying to actually be fully embedded within the real world of a user to actually understand what real interaction and experience looks like. Now, as I mentioned, one of the things that is exciting is we're not only able to do this observation, but we're also able to prototype new experiences. So the first work that you saw was primarily observational work. It was understanding what experience was with these autonomous driving systems. However, the fact that we now have this computational capability built into the devices, that gives us this opportunity to start to sort of change things, to start prototyping experiences, to try out new ideas. And so that's what I'll show you in sort of this phase of the talk, where it's really thinking about building as a way to act and building these devices as a way to prototype. So in this project, I worked with some researchers at Spotify, the music streaming company, and they were quite interested to understand how we might learn about people's music home. So this was an exciting time where Spotify was starting to think about voice-based interfaces for how you would interact with your music. And they were really interested in understanding how these devices might work and how this interaction might work when you're in specific contexts, like when you're driving or when you're in your home. I'll say a few years later, some of the ideas that actually I think were part of this work, there was an idea here that went into CarThing. This was a car device that was especially designed by Spotify to allow people to use Spotify in their vehicles. And then today there's actually a product called DJ, which is sort of a voice-based agent that kind of talks to you about music and puts together playlists for you. So in a similar way, we ran a sort of remote contextual interaction where we have a control interface and designers and researchers at Spotify who are behind the controls. Now, one of the things here is to do this, you have to have some type of remote control of a device. And in this case, it's actually really nice. Spotify actually already had a feature called Spotify Connect. It would allow you to control sort of a desktop music player from your phone or vice versa. So this actually allowed us to basically remotely control someone's music experience. And then in addition to that, we could sort of develop these sort of prototype speech agents. So either interactive radios that we either put in your car or in your home. And then we have this control system here that would allow you to change the music, choose different music. It would allow you to ask questions. And in this case, it would allow you to prototype new sort of voice-based experiences. Here, these are only samples. Spotify had a number of things that they were interested in trying, but that's sort of their research. What I was doing when I was working with them was sort of thinking about how we could use this and how we could help them in that research. So I was looking at sort of the process of doing this sort of remote interaction prototyping. So we did a deployment and we had 3 researchers who were exploring this sort of human-agent interaction. And actually, we did this both in the vehicle and in the home. Today, I'm going to talk mostly about the vehicle ones, mostly for time. But we did this both actually with a number of different drivers who, again, were on sort of their everyday commutes. And then we also did it with a home user in sort of a long-term interaction. The team was quite interested in understanding, okay, well, if you're going to live with this every day, what does it look like for at least multiple days of interaction rather than sort of just that one novel experience of, oh, say the first time I've interacted. And the cool thing is because we were able to do this all remotely, we could basically call in, we could sort of remote control this sort of DJ bot prototype. They were able to do this. We could put this in someone's home for up to, we put it in someone's home for a week, and we were able to then prototype over the course of a week, rather than sort of having to, again, bring someone to the lab or having to sort of set it up and go and do this every time. One of the things that was exciting about this, especially a few years ago, was that we were also able to do this in a distributed fashion. This allowed teams in Boston and in the San Francisco Bay Area to work together to actually either interact with drivers who were anywhere in the country, in our case, though, mostly in the Bay Area, or to interact with people in their homes. For example, we had someone test this out in New York. And so we were able to do this type of prototyping from people in offices all over the country, which was quite exciting, and it really allowed the team to see a lot more than they normally would have if they could only do this where they were trying to do this, say, in their own research labs, or if they were going to people's homes or riding along in their cars with them. In regards to some of the conversation channels that are happening here, what we've sort of done here is actually the way, especially actually there was the team there that kind of had this insight, is we've sort of taken the one-way mirror room. So for those who've ever been in a user testing lab, you may have experienced where you've got a room where there's a one-way mirror. So you, as the researchers, can sit on one side and look through it at your participants, but they don't see you, right? They see a mirror. It's kind of like, also like an interrogation room. And so we've sort of created a digital version of that. And so what's going on is that basically the designers are on the back end. They can talk to each other. They basically can chat with each other over, say, a separate remote call. They can text message each other. They then can use that Wizard of Oz control interface to create this experience for the user with this sort of interactive music agent, but there's never any sort of, it doesn't feel like you're being observed, and you're never sort of getting in the way of sort of having a conversation and being able to talk about, like, what are you observing? That never sort of leaks over into that front channel. So let me show you an example of what some of the things that they were interested in doing. So again, as I mentioned, they were interested in understanding people's how people were sort of learning about music, or how they might be able to talk about music when they were driving, so that it could sort of steer a conversation and steer basically music selection. Here's a clip where a song is actually brought up. So this is an automatic song from the playlist that basically they said, oh, we were trying out some sort of intelligent playlist. Let's see how the user responds to this song.
Mississippi Pop, The Passenger.
Oh, really? I love this song. I actually played it in a band. I love it.
So in this case, they play this song. It's an Iggy Pop song automatically. And they see action, actually. You sort of see the driver go, oh, and they reach out, they raise the volume, and then they say how actually they love this song, and specifically that they used to play this song in a band. So this was exciting. The team actually on the other side was like, oh, cool, we picked a good song. This helps us to kind of think about this. But what they're able to do is by seeing this sort of really exciting interaction, they're able to sort of play on this. And they actually started to prototype different sort of speech-based experiences to say, can we, how would you actually engage more around this, especially what seems to be a very positive experience? So here is their response. So again, they're remotely controlling this. They see this video, and they're controlling now this sort of this computational, speech agent.
I play the drums. Oh, what else did you play? That's what you asked. Do you know from Golden Earring, Renault? That's a neat one, also fits nice to that. A Fool for Your Stockings from ZZ Top.
So he actually goes on to name about 5 or 6 more songs, all songs that he played in a band. And this was quite an interesting experience. Actually, within music recommendation, there is a problem known as the cold start problem, where when you're trying to create a playlist, you got to understand a little bit about people. You have to understand, well, what do you like? What are you interested? What music are you into? This is sort of a really interesting and exciting interaction experience that they sort of recognize, where you could have this conversation, but it could be tied to sort of moments in someone's life. So in this case, some songs that I used to play in a band, and actually by talking about this music, getting a list of all those bands, you could sort of create a playlist and a recommendation thing all on the back end. So this could be something that could be fed into a recommendation algorithm as sort of the seed for something. One of the things that was exciting about this, and actually we found throughout a number of things, that asking questions like, what did you listen to in high school? What did you, tell me what was there a band what was your first band that you saw in college? Things like this. This really got people talking about all kinds of musics that they liked. The other thing too is that most people really enjoyed this experience. Actually, a lot of people don't talk about music with each other as much these days. I think we used to more. And so this was a really pleasant experience. So it was both information gathering and would be helpful for their recommendation engine team, but it was also creating this really positive experience for the listeners. I'll show you one more example of a really interesting thing where the team was able to sort of live prototype, basically improvise a new service idea and then test it out immediately. This is something that they came up with. They hadn't really pre-planned this. They're just trying to basically, think about different interactions. And specifically in this one, it's something that they were able to sort of uncover through their interaction with this driver. So I'll play the clip.
Did you know that TLC is playing on the 15th of July in Concord?
What? I need to buy tickets. Thank you for letting me know.
So in this case, actually, what they do is the Spotify interface, which is what they're looking at to remote control. When music is playing, it will sometimes tell you that there are local bands playing in the area. So it'll say this musical artist has a concert in the area. And I think there's a way for you to say, if you want, you can go buy tickets. They saw this and they said, well, I wonder what we could do. Can we do this in voice? And so they say, did you know that TLC, the band that's playing, there's a concert in the local area? And the driver responds with sort of this, oh my gosh, I need tickets. Again, as I talk about need finding, this was quite exciting, right? This is something that where they're able to kind of really quickly prototype a new idea. And not only that, they can test it, they can see, how does the user respond to this? Actually, they were like, no, this is cool. I'd like to know. Actually, they even had an idea where they said, we can text you the information because they're driving, so they wouldn't want to pull up information on the screen. We can text you this information when you get home, so that you could basically have a link automatically to sort of get that information if you wanted to go purchase those tickets. Again here, really sort of an exciting way to go out and create interaction, but also then prototype sort of new experiences, sort of real time, and then be able to see how people respond to them. So a couple of user insights in regards to sort of the interactions here. One of the things that we found was that a lot of simple interactions really led to quite meaningful conversations. Asking simple questions like, what did you listen to in high school would sort of bring up people talking about long lists of music and all the things. The other thing too was that people really found this as a really value-added experience, right? This was a fun thing to do. It was an enjoyable activity. It also, in the case of being in the car, it made their drive go by a lot faster. In the Bay Area, people are known to have very long commutes. Being able to do something like this and actually have a service where, say, you're listening to music and then talking about music was sort of this interesting idea of like, oh, it could be a way to make a commute feel shorter, even when it isn't. And lastly, one of the things, and I don't show video clips of this for reasons of sort of privacy, is that there were some things that people didn't want to talk about. There were interesting concepts. Music is very powerful, right? People would sometimes talk about like, well, I don't want to listen to this song. And they, might ask, they ask that question, can you tell me more? And they'd be like, well, this reminds me of my ex, right? And I broke up recently. And they're like, whoa, should we dive into this? As user researchers, sometimes we're often really interested in understanding people quite deeply as a way to sort of empathize with them. But in this case, because they were sort of interacting as this bot that was representing Spotify, there was a question of like, well, does Spotify ask about that? Like, or do we just say, oh, it's okay, let's move on to something else, right? Or let's lighten the mood. And so it caused the designers on the other end to really have to wrestle with these sort of kind of challenging moments when things didn't go right, and then almost to think on their feet of like, how should we navigate this situation? Because those situations are likely going to happen. Issues are going to happen. Problems are going to happen. This sort of allowed them to see this and then think a little bit more about what would we do to kind of change the way our systems interact so that we can sort of gracefully move around some of those problems. In regards to the design process, so that in using this method, right, and thinking about doing this in a remote way, one of the things was that it was really powerful for the designers to do this reflection in the moment on their own values and the values of, say, their company and how that interaction should play out. There were a lot of really interesting back-end conversations about like, what should we do? Why should we do this? Does this make sense? Is this what Spotify should do? The other thing too was that just being able to do this in a remote and distributed way was really useful for global teams and teams that were moving often. Actually, we had people who were constantly going to different offices, but they were almost always able to sort of call in and they could continue kind of doing this work. And then the other thing too was, again, we sort of found this thing where because you were remote, because you weren't sitting there with someone and actually with a clipboard or something like that, you could be really flexible in what you wanted to focus on. So for example, you could say, let's focus on, just music selection right now. Are we picking good songs? Are we kind of putting together playlists? Let's think about more improvising different interactive experiences. So for example, the ticket suggestion. So this was really nice. They were able to kind of flexibly move in between these sort of roles. So one of the things that I'm sort of been thinking about, right, we've done this, is sort of thinking about how far we can go. As I mentioned, we're able to do this in a distributed way, and we can actually do these kinds of things for long amounts of time and in places where we normally might not be able to access as designers, where it would be quite challenging. For example, we actually did a thing where we ran this DJ bot interaction on a road trip. So these folks were driving all the way from San Francisco to Portland, Oregon. This is a multi-hour, actually it was a multi-day road trip. And we were actually able to sort of have this sort of DJ bot experience and think about, let's prototype, what does this look like on a multi-hour trip? Like if you're kind of talking with this agent about music and trying to pick the right music to play at different times. The other thing that we've been doing is thinking about it in other situations where we might not always have access to, that sort of are far away, but actually where automation is starting to increasingly become part of sort of people's everyday lives and people's everyday works. This is a project that I did in collaboration with Wendy Ju and Elon Mandel at Cornell Tech, where we were looking at sort of how human operators interact with farm equipment. So again, kind of back to that autonomous vehicle, but now with a totally different group of users using automation. I'll show you just a couple of clips here on what this looks like. So we think about, well, what can automation do on, say, farming? And in many ways, we were quite surprised to see that it looks very different from how we might imagine sort of working on a farm to look. So in this clip here, what you see is, I'll back up there so you can see the slide. You actually see that sort of automated work in this case is actually looking sort of fairly comfortable. The operator here is sort of leaned back, mostly because they're driving quite slowly, and the vehicle is mostly doing itself, except for the fact that it hits a rock, and this robotic cultivator, this is what's on the back end that's sort of weeding things, it doesn't actually see rocks, and so they have to lift up the system automatically. And this was something we were a little surprised to see, and actually made us recognize, like, oh, wow, hey, there's like potentially a new product feature for this, is to actually do a rock detector and then have this thing automatically lift up so that it's not hitting rocks. Because if you hit too many rocks, you can actually break the mechanical systems, which then have to go be fixed and slows you down. I'll show one last clip here because we're always, a lot of the work that I am interested in is not just looking at sort of how things work when they're working right, but actually what happens when things go wrong. That's oftentimes a really exciting place to do need finding, and a place to actually think of new product features or even new product categories when you can see when things go wrong. Here, this is an example of when the automation doesn't work. So here in this clip, the operator's sort of fighting with this robotic cultivator. Basically, what's happening is that the cameras can't see the rows in between. Again, we're able to sort of see this type of interaction, and then we're able to sort of ask questions and understand what's going on. I will say, when I first started doing these observations, I knew very, very little about farming. And so this is really helpful for us to see when things go wrong. We can ask very quickly in that tight interaction between a situation and how people are sort of processing it and responding to it. So here's the operator's response to this.
What was going on through the middle of the field?
Well, it started to get all wonky because the way that the cultivator is pushing the weeds over, it's making it look like the tops of the beets, so then it kind of gets crazy. It's kind of happening down there at the end too. And when I was going down the first time, it was having trouble reading where the beets were, so it messes up every once in a while, but I didn't expect it to be this bad on this new cultivator, to be honest, but sometimes it happens. I mean, there's nothing you can really do about it. It just shows that we should have cultivated this the first time.
So this is a really interesting sort of response if you don't know a whole ton about farming. Partly what's happened is that the weeds have sort of overgrown, and they thought actually they were running an experiment here. They were trying to see, could the robotic cultivator handle a lot of weeds? Turns out maybe not, but it does speak to sort of potentially opportunities in understanding, okay, well, why would this farm want to try to cultivate sort of less frequently? It turns out, well, it's less work, it would be less fuel usage, and it would basically allow them to tend to sort of more fields and stuff. And so understanding that, this is something we could start to learn about to understand, okay, well, how might you then think about the automation systems, or how might you think about new systems that could help, say, with planning or with management of sort of the fields that you can sort of build into sort of this product experience that you have with these sort of robotic farm equipment. So with that, I think I will end here. I'll give some acknowledgements. A lot of the work that I have done in sort of thinking about prototyping these systems and sort of developing ways to help designers understand their users better and then prototype new experiences in the world was done with a lot of partners here. So I very much appreciate their support. At this point, I'm happy to take questions on anything that I've discussed today.
Thank you, Nick. Should we give a round of applause? Oh, thank you. That was really great. I'm going to probably ask the people on Zoom if they want to ask a question just to raise their hands, and then I can open up the mic to people online. But first, I would want to give a chance to everyone who's here. If they want to ask a question about Nick's research, I'll probably just ask you to come forward and face your colleagues so that also the microphone can catch your question. Who wants to be the first? Everyone's maybe a bit shy.
I have a question, maybe. No one wants to go first. Yes? Hi, Nick. Can you hear me?
Yes, I can.
Hi there. So I'm Sandra. I'm from Technical. I'm a colleague of Augustus at the Computer Science and Engineering Department. Thank you for your very interesting talk. I have some questions. I was very curious about I was curious about the designers' experience themselves. I was wondering whether you believe their own experience might bias the results, might bias the interaction, but might play any role on the results that you have.
Yeah, that's a great question. So I think that anytime, so does the designer's experience or their background or anything, does that bias the interaction? 100%. But I think that we're always sort of doing that when we're ever creating anything, when we're ever designing anything, all our past experience, all of our own personal sort of biases are going to likely find their way into the products we design. Now, we can have strategies for trying to avoid that, one of which is simply designing with teams and then actually doing more field testing. One of the things that's exciting here, though, is that because I'm thinking about this in often really early stages of new product development, I'm also looking at people's experience, their own biases, the way they think about things as a way, as a resource, as a way to sort of leverage that into creative new ideas, right? So for example, you know, I may not have actually looked at the sort of ticket sales thing to say, hey, let's actually recommend and see if we can recommend tickets for the band that's playing right now. Partly because maybe I don't go to that many concerts. Like I don't think about buying tickets. Whereas a designer who's like, well, no, I love going to concerts and stuff. Actually, maybe they would like it. The interesting thing here too is that what they're able to do is try it and see. I mean, in theory, that interaction could have gone terribly. Someone could have said, oh my gosh, you're trying to sell something to me. This is awful. Like, why would you say that? And so, but that's not what happened. And so I think that yes, while people's own experiences are going to play into this, I think that happens all the time when we design something. And so the question then really, I think, becomes more use that as a resource, but then test it, test your assumptions, get other people to test it, get other people to try this, right? So in many of the cases that we had here, we had multiple designers who were acting and creating new experiences as a way to generate more ideas. So that's sort of how I would think about this.
Yeah, great, thank you.
Okay, now that we've broken the ice, anyone want to ask a question? It's now or sort of never. Of course, you can always email Nick. I'm sure you can. Let me check Zoom. While we wait, if someone on Zoom also wants to ask, maybe I want to ask you. Oh, great. Can you? Yeah, that would be great.
Hi, Nick. Diogo, also here with the faculty on programs. Super interesting talk and super interesting research, especially for me, the Wizard of Oz with the bot, Alibi, as you mentioned. I was wondering, with the developments in generative AI, how do you see the potential for the bots to actually run things with less intervention from the researchers? And if you're already doing anything around that, would be super interesting to learn about.
Yeah, it's a great question. So we've got generative AI now, which is actually becoming much, much better at generating conversational interaction. Could you have generative AI do this stuff? You know, it's interesting. When I first talked about this long ago, I kind of had the thing of like, no, what designers do is so unique and special, and I don't think that AI is going to be able to really do this. And I'll say at the time when I was developing a lot of this stuff, like chatbots were not great. They were rule-based systems. You know, I don't know if anyone's ever used like things like voice flow. You're writing out all these crazy trees, and it's super brittle, right? It works for a phone tree, but it doesn't really work for like observing it and then asking questions about people's experience. I am less sure today. I actually think there's a lot of things that we probably can do that are fairly generic that you probably would be able to develop. So some of the things, like if I knew I wanted to understand how people's interaction was in a car that was automatically braking and sort of turning and stuff like that, I don't think it would actually be terribly hard now to use generative AI to actually say, okay, we have some trigger signals based on hard braking. Ask a basic question, you know, how did that make you feel? Or, you know, did you notice that? Was that safe? And then even to follow up with that, to basically hear what the person says and then to ask a few other questions. I still think that there are lots of times where you see things. And again, a lot of this is about the observation, and this is where the visual intelligence comes into play, where you then want to ask a question that is still fairly challenging. Now, visual systems are getting a lot better. And in theory, I think you can do a lot of stuff where you're using computer vision and you can have computer vision based sort of triggers of things. But I still think that there's a lot of opportunity for just people observing and then, you know, being able to interpret a situation. But I'm quite interested in that. I'll say this is something that we're thinking about and we want to test. I don't have any results on this yet. And that's why I don't present it, but we are excited about that. If you are interested at all, or if anyone here is interested at all in thinking about sort of semi-automated systems that are going out and doing need finding on behalf of us as design teams, please do reach out to me. I'm always looking for new collaborators in sort of this space. And also because of the CMU Portugal program, if you're a student who's interested in this and you're interested in the CMU Portugal like PhD program, please reach out to me if you happen to be interested in those ideas.
Here. Yeah. And I don't know if everyone is aware, but actually there's an open call right now for a dual degree, PhD dual degree with CMU. So that's a really nice shout out that Nick gave us now. Do you have any questions? Still mustering some courage. I have a question, probably first a comment and then a question, Nick. Sure. It was just so lovely to see like when the person got scared when she was driving and there was this, and it was always nice to see these sort of heuristics at play. That there was like again the system visibility or sort of the way that the system was making these decisions wasn't very clear to the user, And it's really nice to see these sort of old heuristics still being so relevant when we're doing these kind of things. Because sometimes we show them to students, and the students start sort of rolling their eyes, oh, again with the heuristics. But it's so nice to see that even, and again, in these sort of modern systems, that they're super important. And I've been in those situations where you're driving these sort of semi-autonomous cars, and you're just trying to build a model of what the car is thinking. And it's just so hard because they have like small LEDs that tell you that some things are on, some things are off. So it's really nice to see. So the question I actually had was, I saw a lot of your examples are on these sort of semi-private spaces cars. So it's sort of like labs on wheels, right? And
yeah.
Have you guys applied these sort of methods to, for example, the home, which is quite a private space where there are other people, children, and would it work? Would it scale to those kind of environments?
Yeah, so it's a good question around like what spaces can we do this in? So we have done it in the home, and we have done it in situations where, so we did the Spotify one we did in the home a couple times, and we did sort of work with people to like tell others, like if they had other people in their apartments or their houses, like always have systems that have lights on them or something that says like I'm recording. We always make sure that someone's aware that they're doing an interactive test, especially when, and they know that there are people on the other side. They don't know who those people are, but they often know that there are people observing. They may not know that they're controlling the sort of agent, but they know that there are people sort of watching and making sure the system's working and stuff. And so we have done this. It can work. You have to sort of work with your participants, with your users. This is something where actually, per the last question, I think it can get really interesting when you have systems that are running more on their own. So you're using generative AI to potentially do this type of conversational interaction, because then you can do this in a way that's a bit more privacy preserving, right? You can sort of have the systems ask questions. And so that's something that we're potentially interested in exploring. And then the other thing that we've been thinking about is actually going the other way from sort of just totally private spaces to even in public spaces. One of the things that we're quite interested in today, we're doing some research. I have some students excited about public robots, so things like delivery robots, and then thinking about, well, what's it like for someone who's trying to navigate around this robot, especially folks who are maybe use mobility aids like a wheelchair. So one of the things we're actually planning to do is sort of to do this type of interaction, but instead of sort of, being in your car, you might be sort of riding on your wheelchair out in public, maybe wearing headphones, maybe AirPods. And so in this case, you can sort of have a conversation more like you're on a phone, and we can simply set up a camera that's maybe mounted to your wheelchair and stuff. So it is possible. I actually think that it requires a lot of work from the design team to sort of make sure you have consent, make sure that the participants are aware of sort of what they're doing. And then, like I said, potentially maybe with more automation and AI, this stuff could become more easily done in private spaces because it isn't sort of a human team on the other end, but it's simply an agent acting on behalf of a human team.
Thank you. Anyone? Otherwise, I'm going to ask one more question. I don't want to monopolize everyone's time, but I'm going to ask one more question. So we talked about Gen AI as a way to replace the designer, right? Have you thought of virtual reality to replace the environment so that you can actually get people in an immersive? So now we're getting headsets that are getting cheaper and cheaper. Like you can get a MetaQuest for $500, 500 euros. Have you thought of going the other way around? So if you want to collaborate on that area, we would be quite happy to have a chat afterwards. But yeah.
Yes, we have. Actually, in the same project that I just talked about, which is robots in public. So one of the things about robots in public, or really anything, doing a lot of this stuff in public, is that it can be dangerous. Actually, we've had incidents here in Pittsburgh where robots have prevented people in wheelchairs, a young woman in a wheelchair, from getting back up from the street onto the sidewalk, and she had to sort of navigate around it. It was kind of it really wasn't great. It's kind of a scary experience actually for someone if they're like, I got to get out of the street and I can't get out of the street because this robot's not moving. So what we're thinking about now is actually exactly that, building sort of digital twins of public environments, and then having people experience these types of situations with these more maybe automation technologies like robots, but then being able to do these types of interactions, these sort of need-finding interactions by setting up situations. And that's kind of the exciting thing about simulation-based systems, is that we can sort of make anything happen We can say I have a really challenging situation with a robot in a wheelchair in a place where the sidewalks are bad and people are parked on the street, people are parked on the sidewalk, and you've got cafes and cyclists going by. We can do all that stuff and then actually do this similar kind of thing where then you can have this sort of need finding machine interaction, but in a virtual world. So yeah, be happy to talk about that more, because that is something that we're actually moving a lot of our work into, especially when there's situations where things could be potentially dangerous, or they can be something that you might not want to test immediately out in the real world. Like, it's one thing to have a bad conversation about music in someone's, on someone's kind of radio. It's another thing to say have a robot that actually prevents someone from navigating safely.
Yeah, for sure. Oh, that's great. Okay, should we let Nick go? I think so. Nick, thank you so much for your time.
Yeah.
And I'll probably invite students to have some questions to send you afterwards if they want to engage with you in some other capacity. If that's okay.
Happy to do so. My contact information is here, nickmart@cmu.edu, and I'm happy to receive emails and chat more about any of the ideas here with folks.
Thank you, and I hope you can visit us at some point in the future. So let's thank Nick one more time for serving. I'm gonna let you go. Probably just show my face once so you know that's it's me on this. Thank you.
All right.
Thank you again. See you around.
See you around. Thanks all.